Okay, this is my Chapter 2 reassessment. I chose a simple basic problem from Chapter 2 to do first to show you that I can do a basic momentum problem using the momentum principle. Inside a spaceship in outer space, there is a small steel ball of mass, 0.25 kilograms. At a particular instant, the ball has a momentum -830 kilograms meters per second. At that instant, the ball is being pulled by a string which exerts a net force 10.250 newtons on the ball. What is the ball's approximate momentum 0.5 seconds later? I decided to write out my variables here, and I put here that this is the variable that I'm looking for, which is the second momentum, which would be after the 0.5 seconds. So here's the momentum update formula for you. Here's it written out. I showed that you would distribute first your change in time to the net force, which I wrote in the second step out for you. And in the final step is the final answer. Once you add together the distributed net force and time plus the first momentum, that gives you your second momentum after the 0.5 seconds. And then I did a more difficult problem, which I felt was more like the one we had in class for our second standard. Suppose that you have a fan cart whose mass is 0.5 kilograms, and with the fan turned on, the force acting on the cart due to the air and friction with the track is 0.200 newtons and constant. You give the cart a shove and you release the cart at position 0.500 meters with initial velocity 0.300 meters per second. What is the momentum of the cart 0.6 seconds later? What is its velocity at that time? So again, I write out my variables. So you have to do a little bit more work here. You have to find the net force, which I did, change in P over change in T. Found the net force, which I'll need later. I also found the change in momentum, which is the mass times the velocity, which I'll also need. I wrote that the variables I need are final velocity and the momentum at time 0.6 seconds. So first I'm going to find P2, which is the second momentum. And this one's a little bit different and trickier because we have, as you can see here, a track, which has to do with the air and friction force, which is 0.2 newtons. So that goes here as your net force. So you plug that in. You do the distribution again like I did in the one before. Add that together, and you get P2 here. Then I can find my final velocity by taking that final momentum and dividing it by the mass, which was 0.5 kilograms. Kilograms cancel, and I get my final velocity as 0.5400 meters per second. And that's it.